So the task one asks you to do authorities and hubs computation, and for that you have to create a root set, and then from the root set you have to create a base set. So for this algorithm, I have assumed that the base set is the input. So I'm assuming you know how to do the how to create the base set because it's given in the project description. So after you have that, you have to have two vectors, AI and HI, which are initialized to A0 and H0, where you can take that as all ones or all 1 by n's, where n is the size of the m. And then you will find the m transpose, and then this is the core of the algorithm, where iteratively we find and update AI and HI. So you have to check if the largest error, I'll get to that, what the largest error means, is if it is greater than whatever your threshold value is. Then you store the previous authority values and previous hub values for all the nodes that are in your M, and then update it to the current authorities and hub values using this formula, which is the same, which is picked from these slides. And then you normalize each of them separately, and then compute the largest error, and then you keep looping. So the largest error is the difference between a value in the corresponding position in AI and AI minus 1. And it's the same way you have to compute it for hubs. Whatever is the max, take that, and then you have to iterate over this. Do you guys have any questions with this?
What if we use the second form of the equation, multiply m transpose m first and multiply m transpose, and then use that to calculate a and h?
You can do that. It just involves multiple multiplications. And one of the questions is, how would you decide what should be the threshold value? I would go about thinking on the lines where 25k is the number of documents that I have. So if I take the initial value here as 1 by 25k, then it is 10 power minus 5. So definitely the threshold should be lower than that. So 10 power minus 7 or minus 9 or something like that.
The largest error, it is the difference of AI minus 1 and AI, right?
Yeah, these two are one-dimensional arrays, so we have to take the corresponding elements. That is, we are checking by how much the values have changed for a single node. And whatever is the maximum difference for all the nodes, we are taking the maximum of that.
Yeah, the previous equation. Yeah. Like you grow.
Also incoming.
Okay.
In degree and the incoming and outgoing, both links.
All within the base set.
Yeah.
There could be a node which is pointing from outside into this one. That is not considered.
You don't have to consider.
You have
That
to
will
consider.
be a part of Ken citations.
Why do we need the incoming links? Because we are only taking care of like what is going from P to Q, and that would be the part of adjacency matrix. So why do we need like this?
What we are preserving while constructing this small graph is the in degree and out degree of the nodes in the base set.
Okay.
Sorry, root set.
Okay.
shall I erase this?
Yeah, you take the root set and then go that into this. Like get.
PageRank scores for all the documents once. So you can store it again and you can serialize it. You need not compute it again and again. Input I've written as link files because we're not going to create a matrix unlike authorities and hubs. So we are going to compute rank on the fly. So this is done because it takes a lot of space to store a 25 by 25 matrix. So what we are going to do here is initialize the rank matrix to 1 by n, where n is the number of documents, and till convergence we are going to repeat this part of the code where we store the previous rank, which is a one-dimensional, which is a vector of ranks of all the nodes, that is nodes are documents here, and for each possible row that is a document, we are going to compute that row on the fly and then update the rank for that document using the formula. Now, doing this part is the most crucial part, and I don't want to give the full pseudocode for that because you need to figure that out, how to do that. But the tips that I can give to do this is to, you have to think about how are you going to first construct the adjacency part of the matrix, and then how are you going to normalize it, what should be the value that you need to consider so that you can normalize an entry in this, and then you have to see where the sync nodes are and how are you going to track that and how are you going to use that when you're going to update this. And then I think that should, multiplying it with I think C and 1 minus C, you need to take care of that. Other than that, this is fairly simple. Yeah.
So the compute row is the part where we generate the m star.
Yes.
That's
A row in an M star.
a row in m star.
It varies depending on what is going to be your initial values. You can take it as all ones as well. So it depends on how you are going to construct the whole thing. Here I have not put the normalization step. I think I should just add that.
While giving out the top 10 results based on the PageRank, do we consider only the top 10, the query results and the PageRank of those results only, or the PageRank of all, and substituting the top 10 values again? So
once you have computed the page ranks, then I think there was a formula that is given on the description page, right? It says I think 1 minus C into PageRank value plus C into cosine distance or something like that. Does anyone have the similarities? So when you have the PageRank values for all the documents, all you need to do is a lookup and then multiply it by the corresponding
Yeah, so my question
weights.
is, we have to do this for all the documents or just the top 10 queries?
This is one-time
No,
computation.
not that, but this time. So suppose you provide
Yeah,
a query
you have to do all
for all the things.
Yeah, because based on weights, it's going to change.
Yeah, well, that's what I'm asking.
This is going to be m multiplied by rank. Rank is equal to m multiplied. Because rank is 1 by 1. M is 1 by n.
But this is a single, it's not a 2D array. So it doesn't matter how
M is a row, right? So M is a row. You are computing a row. So its dimensionality is 1 by n. So you will multiply that with rank. M multiplied.
That's right. But it is equal, right?
Yeah, in that case, we have to just do transpose. I mean,
It's the final component is a scalar, so I think it is.
the value might be the different.
I'm not sure.
Can you explain me the last part, like finding the largest error? Sir said that we should reach the steady state. So how we will get? I didn't got that.
So ideal steady state is when the values don't change at all. So you will be using double precision, right? So that is a lot of precision. So you can have define your own threshold and then check the page rank for a node, the previous values and the current value, the difference in that, which is the maximum difference. That is the largest error.
Okay. So we should reduce the error. That is the.
Yeah.
How do we set the threshold value? We can just randomly select some values.
Yeah, the threshold value, so the way to go about is there are 25,000 documents. So that is the initial value will be 1 by 25,000, which is of the order of 10 to the power of minus 5. And so your threshold should be much lower than that.